So yesterday we were finding three things. Critical numbers, right? Where was the function f increasing or decreasing, right? The original function, where was it increasing, where was it decreasing? And then maximum and minimums, relative maximum and minimums. Okay, that's what we were doing yesterday. Today, we're going to change it just a little bit. Today, we're going to be finding absolute maximum and minimums. Absolute. Okay? So absolute means the overall highest point, the overall lowest point, right? Relative are just mean a high point, right? A change from increasing to decreasing. Any change from increasing to decreasing is a relative maximum. Any changing from decreasing to increasing is a relative minimum, right? This is a little more specific. So today what we're going to do is we're going to find the absolute minimum and the absolute maximum. Okay? So how are we going to do that? How do we do that? Well, it's called the extreme value theorem. Extreme value theorem states that if a function is continuous on a closed interval, so from one place to another, from the starting spot to an ending spot. The ones we did yesterday didn't have intervals, right? There were no intervals here. They were open intervals. This one will have closed intervals. So from this value, starting point, to this value, ending point. Then f has to have an absolute maximum and an absolute minimum, at least once. Okay? So the minimum and maximum of a function are extreme values, or extrema, of the function on the interval. The minimum and maximum, the overall minimum maximum called absolute. Sometimes they're called global, but most of the time you'll hear them called absolute maximum and absolute minimum. So extrema can occur at interior points. Interior means inside the interval. Or it can occur where the interval starts or where the interval ends. Okay? So when we're doing this, we want to be sure to check the beginning of the interval, where it starts, where it ends, and any critical point in between. Okay? Those are the points we're going to check. And then we're going to look for the highest y value. The highest y value is the max, the absolute max. The lowest y value is the absolute min. Okay? So that's essentially what we're going to do. Where do we start? Anytime we're doing any type. So anytime you're doing a problem that has a maximum or minimum, they want you to find a maximum and minimum. You always start with the critical points. The critical points. Start there and go from there. That's what we're going to do. So we're going to start the same way we started yesterday. So let's look at the next problem. Example number 4. So this one is absolute maximum. And we have an interval. We always start. So it doesn't matter if it says absolute or relative. We always start the same way. Find the critical points. Find the critical values. So how did we do that yesterday? How did we find the critical values or the critical points? Started with the derivative, right? We always start with the derivative. So let's do that. So we get 3x squared plus 18x plus 27. That's the derivative of f prime. What did we do next? What did we do after we found the derivative? Set it equal to 0, right? Okay, and then solved. Well, this guy's a trinomial. So trinomial, the steps are up there. I'm doing that with my Math 3 class, so it's the same steps. Set it equal to 0. Needs to be in standard form. Done. Factor out a GCF. This guy does have a GCF, right? It's got a GCF of 3. I can divide them all by 3. And then, like I said, just kind of like we did yesterday, however you were taught in Math 2 and Math 3, the way I teach is using the X method. So I multiply A times C, add up to be B. So is that going to be 3 and 3? So you get X plus 3, X plus 3. Okay, set them all equal to 0. X plus 3 equals 0. X plus 3 equals 0. And then 3 equals 0. Set all the factored terms, I should say, equal to 0. Well, 3 can't be 0. So that's not going to give us an answer. And then subtract 3 from both sides. We're going to get the same answer twice. A repeated answer, a repeated root. So we get one critical value. Just repeated twice. Okay? So we have a critical value of -3, right? That's what our critical value is. Same way we started yesterday, right? That hasn't changed. This is where we're going to kind of change a little bit. I know that -3 is either going to be a maximum or a minimum, right? Judging by what we did yesterday, right? Didn't all of our critical values always end up being maximum or minimums? All of our critical numbers or critical values always ended up being maximum or minimum. So I know that one's going to be a maximum minimum. I don't know if it's going to be a relative or if it's going to be a absolute. So this is where I check. So this part's going to be a little bit different than we did yesterday. Give me 1 second. Here we go. Okay, so now what we're going to do is I'm going to create an X and Y table. Or in this case, since they don't use Y, they use f of X, we'll create an X, f of X table. I'm going to choose the X values I always choose. They told us in the notes, be sure to check all of the following. The beginning of the interval. So where was the beginning of this interval? So I'm going to choose -5. The end of the interval. Where is the end of the interval? -1. And then any critical points within the interval. So is there did I get a critical value or a critical point inside the interval? Yeah, -3 was inside the interval, right? Whichever value over here gives me the highest value, that's going to be the absolute maximum. Whatever value gives me the lowest is going to be the absolute minimum. So this is where it veers off a little bit. We're not going to plug these into we're not doing first derivative tests. We only do first derivative tests for increasing, decreasing, relative, maximum, minimum. This one, we're plugging them into the original. So I'm going to plug in -5 into the original. Okay, so -5 cubed plus 9 times -5 squared plus 27 times -5 plus 3. And then I'm going to do the same with -1. And the same with -3. Okay, so you would just do order of operations. You would just do PEMDAS, right? To save us some time, I'll just give you the answer. So if you were to do PEMDAS, you guys have been doing PEMDAS since elementary school, so I'm guessing you guys can do that fine. But just to kind of speed it up, when I do -5, when I plug in -5, you're going to get +32. When you plug in -1, you're going to get -16. And when you plug in -3, you're going to get -24. So if you were doing this on your own, that's what you would do. I'm just kind of speeding it up just for, since this is notes. Okay. So what was the biggest y value? What out of those three, what was the biggest, the biggest number, I should say, the highest number? 32, right? That's my absolute maximum. 32 is my absolute maximum. What is the lowest or the smallest y value? -24. So that one's going to be my absolute minimum. -16 is just a relative. -16 would just be a relative maximum or minimum. I don't know if it's a maximum or minimum, but it would just be a relative. But it didn't ask us for relative, so I'm not worried about that. I just want to know the absolute maximum. Well, the absolute maximum sorry. No. I read my notes wrong. This is actually -32. Let me rewrite this. Sorry. Thought it was positive 32, but I read my notes wrong. It's actually -32. So that's going to change it a little bit. That's going to be the absolute minimum now. And the absolute max is going to be -16. Okay. So we would say absolute max occurs at -1, -16. So if I was to graph that guy from -5 to -1, the highest point would be at -1, -16. The lowest point would be at -5, -32. But you guys are copying that. I'll go to Desmos and show you guys. Third sine x squared plus 27x plus 3 what was it from -5? That's not working. Okay, so here we go. I'll show you the graph. Let's see. So we're only looking from not looking on the phone. We're looking up here. Thank you. Okay. From -5, so -5's here, to -1. So from -5 to -1, the low point is at -5. The high point is at -1. Okay, because the low point is here, and then it's increasing. Okay. So without graphing, it tells us that much. It tells us all that we need to know. Okay. All right. Okay. All right, so next one. Example number 5. This one, they want absolute minimum. Absolute minimum. Okay. Same thing. We're going to do the same thing. It's just we're looking for the lowest value instead of the highest value. So absolute minimum. Here's the interval. Okay. Find f prime. So f prime -4x to the third plus 12x squared. Set it equal to 0. It's a binomial. Like I said, my Math 3 students are doing this right now. So if they can do it, I know you guys can do it easily. But if you're not sure, these are the steps to factor a binomial. GCF, -4x squared So you get x minus 3 -4x squared equals 0. X minus 3 equals 0. Solve for x. Divide by -4. X squared equals 0. Take the square root. You get 0. Add 3 to both sides. You get 3. So you get 2 critical values. 2 critical values. 0 and 3. Set up my table. First thing to check is first thing you're going to check is your the start of the interval, right, which was -2. End of the interval, which was +4. Any critical values inside the interval. Are 0 and 3 inside of the interval? Yes. So we're going to check both. If one of them was not inside the interval, we wouldn't check it. Like if 3 was -3, we wouldn't check it. I wouldn't need to put it in my table because it's not in the interval. Only values within the interval. Okay? So we're going to plug in to the original. Be careful when you're plugging to the original because the original starts with a negative in front. So it's -2 to the 4th plus 4 -2 cubed plus 8. And then -0 4th plus 4 0 cubed plus 8. Okay. So when we do order of operations, we get, let me see my notes. For -2, I get -40 when I plug it in. For +4, I get +8. For 0, I also get +8. And then when I plug in +3, I get +35. Make sure my signs are correct. Yes, that's right. Okay, it's just order of operations. You just do parentheses, exponents, multiplication, division, just go like that. But just to kind of save some time. Okay, so we're looking for the minimum. That means the lowest number here. Well, the lowest number appears to be -40. The highest number appears to be 35. They didn't ask us about that, but that would be the absolute max. So absolute minimum occurs at -2, -40. So if I was to graph this guy, that would be the lowest point. The lowest point from -2 to 4 would be at -2 at the beginning, at the very beginning. The highest point would be at 335. Okay. All right, so the last one is exactly the same. The only difference between 4, 5, and 6. Oh, so change 6. Change it to, instead of, we did one earlier where we had a fraction, so we haven't had a natural log one. So put this one in there instead. We're going to do the same steps. It's the same exact steps that you've been doing today. But we haven't had a natural log one, so I wanted to put one in your notes. So it's the f of x is the natural log of x plus 1, and then the interval is from 0 to +3. Okay. Okay, we'll do this one together, and then we have some extra time. I'm going to give you a few problems to try on your own. Okay, so first thing, find the derivative. Well, we just did a whole test, a whole chapter where we were finding derivatives. So how do I find derivative of natural log things? It's a lot easier than you think. How do I find derivative of natural log things? The derivative of the inside, which is just 1, right? That goes on top. What goes on the bottom? Itself, whatever it is, x plus 1. Done. Okay. So that's the derivative. Next step, set it equal to 0. How do I solve this guy? There you go. Set the top and the bottom equal to 0. Good. Set the top to equal to 0. So that would be x equals 0. Or sorry, 1 equals 0. And the bottom equal to 0. And solve for x. 1 does not equal 0. In no way will 1 ever become 0. So I'm not going to get an answer from the top. The top won't give me an answer. That's okay. The bottom will, though. Subtract 1 from both sides. So I get 1 critical value. So they want absolute, right? So since they want absolute, we go to our table. X, f of x. I will start with the beginning of the interval, 0. The end, 3. And then I had a critical value at -1. Do I put that in my table? No, why not? Because it's outside the interval. I'm only checking inside the interval from 0 to 3. -1 is not inside the interval, so I don't check it. So I only check, there are no critical values in between 0 and 3. So I just check 0 and 3. So I plug in natural log of 0 plus 1, natural log of 3 plus 1. So this gives me natural log of 1. This gives me natural log of 4. One of them is going to be the bigger number. One of them is going to be the smaller number. Which one do you think is a bigger value? Yeah, natural log of 4. Because remember, natural log of 4 is kind of like saying e to what power makes 4? Well, e is around 2.7, 2.8. So it would be, like between 1 and 2, the power would need to be between 1 and 2. So this value here, no, I don't want that, is between, this is equal to, or be somewhere between 1 and 2. This guy over here, the natural log of 1, what is that equal to? Well, that's like saying e to what power equals 1? That's equal to 0, right? That one's 0. So this guy is between 1 and 2. This guy is 0. So, yep, the bottom is going to be the max. Absolute max. And the top is the min. Since there was only 2 points that I checked, since the critical value was not in the interval, let me write that down in the notes. Not within the interval. I'm not going to check it. It's not going to go on my table. So the absolute minimum, 0, 0, or 0, natural log of 1. The absolute maximum, 3, natural log of 4. I don't know what the natural log of 4 is, but I know it's bigger than the natural log of 0. That's it. You're done. So it's not any different when you're using natural logs. It's not any different when you're doing trig stuff. All that stuff is not any different. Okay, let's see here. All right, so let me give you some problems. Okay, so this is what I want. So we'll call this example number 7. So you should have some room on the bottom of that page. Example 7. So this one, we're going to kind of go back to what we did yesterday. I want you to find all intervals of increasing and decreasing and relative extrema. Okay, so f of x is x times the square root of x plus 3. So for this guy here, I want you to find where is it increasing, decreasing, and where are the maximum minimums. So I'll give you a hint. It's not what we did today. It's not asking you for absolute. It's asking you for what we did yesterday, first derivative tests. Okay? Give that one a shot. I'll give you about 5-ish, 7 minutes, something like that, and then we'll go over it. I want you to try it, and we'll go over it, like I said, about 5 to 7 minutes. Okay? Okay, so the hardest part about this one is probably finding the derivative, but we've spent a whole chapter doing that, right? We spent all of last chapter learning how to find derivatives. Well, now we're using them. So the first thing we have to do is find the derivative. Well, the derivative, or the original, is x times the square root. Okay, so I change it to a power. And then I use the product rule. The first times the derivative of the second. Well, the derivative of the second, you need the chain rule. So you move the 1/2 to the front, rewrite it, subtract half a power, and find the derivative of the inside. The derivative of the inside is just 1. So, I mean, you can have a times 1 there if you want. And then the the derivative of the first, which is just 1, times the second, rewritten. That part wasn't too bad, but the next part is where it kind of gets a little tricky. Now you have to solve it for x. So I rewrote it as a root. Both of these answers are the same. So this answer and this answer are both exactly the same. One has roots and fractions and one doesn't. Well, to solve it, right now we have 2 fractions, right? I have this guy and then I have this guy. To solve it, I'm going to need to combine them. So to combine them, I need common denominators. So this one's just got a denominator of 1 right now. Well, it's missing a 2 and a root x plus 3. So the common denominator for both is 2 root x plus 3. So the first guy just gives me an x. The second guy, I'm going to have 2, but then I have these 2 guys multiplied times each other. So when I multiply these 2 guys times each other, what's going to happen? The root's going to go away, yeah. So it's just going to be x plus 3. Okay. So I got to do a little bit of distributive property, distribute, and then combine, you're going to get 3x plus 6 over 2 root x plus 3. Mm-hmm. The x, what x? The x, what x did in front of the 2. When I distribute, so when I distribute, I just distributed here.
Yeah, so would the x just go away? The one in front?
No.
The one in front?
No, where'd it go? When I multiply here, what do I get?
It's 2x.
I have 2x, right? That's not 2x.
Oh,
Yeah. Okay. So now that I have a top and I have a bottom, I can just set those equal. So I get 3x plus 6 equals 0. 2 root x plus 3 equals 0. So here's the thing. The hard part about this has nothing to do with calculus. So everyone, calculus is hard. No, it's not. It's everything else that's hard. Okay? This stuff here, roots and stuff you did in math 3. Setting equal to 0, solving. Like everything that you can see right now, there's no calculus. Common denominators, right? Distributing, setting equal to 0. That's not a calculus thing. That's something you did before calculus. Okay? So set it equal to 0. So I get 3x equals negative 6. Divide by 3, divide by 3. I get x equals negative 2 as one of my answers. Over here, I'm going to divide by 2. To get rid of the root, I got to do the opposite. So the opposite of a square root is squaring. Once I get rid of the root, I can subtract 3 from both sides. Negative 3. So I get 2 critical values. Negative 2 and negative 3. Okay. So now I'm going to use those to figure out where is it increasing, where is it decreasing, where is it relative maximum, where is it relative minimum. Okay, so number line, this is where I do the first derivative test. So I got negative 2 and negative 3. Okay. So I need to plug in a number to the derivative that was less than 3, negative 3, in between negative 3 and negative 2, and greater than negative 2. That's the last thing I have to do to figure out where is it increasing, where is it decreasing. Well, the derivative is here. Again, I don't care if it's positive. I don't care what the number is. I don't care what the number is. I just want to know if it's a positive number or a negative number. So I'm going to plug it into the derivative, which is right here. That's the original derivative that I got. So pick numbers that are, smaller than negative 3. What's going to happen when I plug in numbers that are smaller than negative 3, though? I'm seeing that right now. Negative 4, negative 5, negative 6, negative 12, negative 100. What's going to happen if I plug in negative numbers there? Yeah, it's going to be imaginary, right? Because it's going to turn imaginary in here. So we're not worried about this. So it's not going to exist there. Okay, so let's go in between negative 3 and negative 2. Let's try negative 2.5. So I get negative 2.5 over 2 root negative 2.5 plus 3 plus the square root of negative 2.5 plus 3. Is that going to be a positive or negative answer when I solve it? I don't care what number it is because I don't have a calculator. I don't care. I just want to know when I do these, am I going to get a positive or negative answer? So you got to kind of use your number theory. This is mental math. Those of you guys that like mental math, there you go. Is it going to be a positive or is it going to be a negative? Well, let's look on the bottom here. Let's start with the bottom. Am I going to get a positive number or a negative number when I do that math? Positive. You're getting a positive a half, square root positive times 2. On top, I get a negative, right? Okay. Over here, am I going to get a positive or negative? Positive up here, positive down there. Okay, so I'm going to get one fraction that's positive and one fraction that's negative. Which one will be bigger? The first fraction or the second fraction? That's what I got to decide. If the first fraction is bigger, it's going to be negative. If the second fraction is bigger, it's going to be positive. So which one of these guys is going to be bigger? This fraction? Give me a bigger answer, I should say. So when you have a fraction, how do you know which fraction is bigger? What determines if a fraction is big or small? The what? Say it again. There you go, the bottom, right? That's where you're dividing by, right? I could have a huge number on top, but if I also have a huge number on bottom, doesn't matter, right? If I have a small number on top, but an even smaller number on bottom, it's going to be big, right? So let's see. This one's 1. One of them's 1. This guy over here, 2 times the square root of a half. Well, the square root of a half is like a fourth, I think. Let's see. No. So this guy is going to be pretty small, right? You're going to have a small number over 1. This guy's a big number over this. So this is pretty much double this, right? Let's see. It's actually pretty close. Pretty close to 0. Let's see. So this one's going to be a pretty small fraction here. This one here, though, is the same number, doubled, still a small number, divided by this. So I believe the first one's going to be smaller, or bigger. The first one's going to be bigger. So if the first one's bigger, it's overall going to be negative. That's about the hardest mental math you'll have to do in this class. Most of the time you have to do mental math, it's pretty obvious. One more, and then we're done. Pick a number bigger. Pick a number bigger than negative 2. 0 is always a good one. Pick round numbers, not like, I have 10, 5, stuff like that. So again, the first one's going to give us a negative, right? Say what? Was that? Oh, you're right. Yeah. Makes it easier, right? Also 0 on top. Thank you. Yeah, that makes it a lot easier, right? Because this one's going to be just 0. The second one's going to be a positive number. So that means overall we're going to get a positive number. Positive root 3. So before negative 3, it doesn't exist. Before negative 3, the graph does not exist. Because it's going to give me a imaginary number. We can't graph imaginary numbers. Okay, so decreases, it starts decreasing, and then quickly at negative 2, it starts increasing and never stops increasing, right? So we're only going to have one extrema here? Is it going to be a maximum or minimum? It's going to be a minimum. Relative minimum at x equals -2. Okay. All right. So if it's a relative maximum, you do the first derivative test, relative maximum or minimum, increasing, decreasing. If it's not, if it's absolute, you do what we did earlier. Make a table, or you find the derivative, find the critical values, and then set it equal, put it in a table. Okay? All right, so tomorrow I'm going to give you the practice assignment. I'll let you work on that tomorrow. Okay, so tomorrow we can do that. And then Thursday we'll go on to the next set of notes. Okay?